Hello, 7th graders. All right, so we're in section 3.5, graphing linear equations in slope-intercept form. Now, you might be asking yourself, Mr. Humphreys, we've done slope-intercept form, and you would be correct. Once again, you are more than welcome, absolutely more than welcome, to skip over parts of the video that you already know. That's one of the great things about this setup, is that you can go through and be like, I already know it, you can skip ahead. But I'm still going to go over parts of it that maybe some people don't know, but then we're going to skip examples and go right to the new stuff. So you can just skip right on ahead to the new stuff if you want. All right, so let's look at a reminder of what slope is. Slope, as you should know, is change in y over change in x. It is the rate of change between any 2 points on a line. It is measured using the steepness of a line. So, to find the slope of a line, it is a ratio. The slope is a ratio of the change in y, which is the vertical change, to the change in x, which is the horizontal change. So, what does this chapter go over, or what do we learn? What you're learning is how to find the slope, how to use slope-intercept form, and in real-life problems. And that's the new stuff, is interpreting this in the way of a function. So this right here goes over how we find the slope. Once again, the slope is where you find the difference in the y values, which is the change in y, the difference in the x values to find the change in x. And as you already know, when we look at slope, we go from left to right. If the line goes up from left to right, if it rises, I should say, not goes up, but if it rises, it's a positive slope. If it falls, it's a negative slope. A horizontal line is a slope of 0, and a vertical line is an undefined slope. Now, slope-intercept form. You've done this before. Slope-intercept form is what? It's a linear equation that is written in the form y equals mx plus b. The m stands for your slope, the b stands for your y-intercept. Now, a linear equation written in the form y equals 0x plus b, or y equals b, is a constant function, which would lead to a horizontal line. So as you know, the equation is solved for y. So if you had y equals x fifths plus 2, the slope would be 1/5, and the y-intercept would be 2. So example 1, this is new, so I would suggest you write this down. You're going to graph from a verbal description. A linear function g models a relationship in which the dependent variable increases 3 units for every 1 unit the independent variable increases. Graph g when g of 0 is 3. Identify the slope, the y-intercept, and the x-intercept of the graph. So let's look at what we have here. We know, because it's linear, it has a constant rate of change. That's important. So we know this has a constant rate of change. Now, independent. What variable is the independent variable? Good. That's right. The independent variable is x. The dependent variable is y. So we know that the change in y, right here, the dependent variable increases by 3. So, change in y divided by change in x, the slope would be increases 3 for every 1 unit for independent variable increases. So that means my slope is 3. Now, it says graph g when g of 0 is 3. So that means this function at the value of 0 is 3. That means that's my y-intercept. So my equation would be y equals 3x plus 3. There you go. So what's my slope? My slope was 3. What's my y-intercept? It's 3. What's my x-intercept? Well, you can graph this. So 3. My slope is 3, so up 3, right 1. Or I can go down 3 units, left 1. And so my x-intercept would be -1. So my slope is 3, my y-intercept is 3, my x-intercept is -1. Now in our last example, we're talking about real-life problems. Now, as in real-life problems, in most of them, slope is interpreted as a rate, such as miles per hour, dollars per hour, people per year. That is usually what slope is always interpreted as. So in example number 2, we're going to talk about a submersible. So a submersible that is exploring the ocean floor begins to ascend to the surface. The elevation h in feet of the submersible is modeled by the function h of t equals 650t minus 13,000, where t is the time in minutes since the submersible began to ascend. Graph the function and identify the domain and range. Interpret the slope and interpret the intercepts of the graph. So right here I have our function. We know t is time in minutes since the submersible began to ascend. So where is the submersible currently at? At 13,000 feet, below the water. So let's make a graph. Now we're not going to use x and y. T is our horizontal axis, and h of t, or h, is our vertical axis. We're starting at negative 13,000. So I'm going to count by, let's do 2,000s. So here's my graph. Obviously we have labels. We've labeled our axes. And I have increments written on the grid. So what do we know? We know this starts at negative 13,000. So this would be, let's see, this is negative 14. So negative 13,000 would be right here. Now it ascends 650 feet per minute, as written by the slope. So I don't want to see where I'm going to go. I'm just going to go straight to the x-intercept. The x-intercept. If I want to find the x-intercept, I plug in 0 for h, the height, because I want the height to be 0. So 0 equals 650t minus 13,000. I add 13,000, divide by 650. The value of t is going to be 20. So I'm going to put a dot at 20. I am then going to connect those, and there is my graph. So part A is the graph, and we also want to give the domain a range. So the domain. Well, what is the value of t? The value of t minimum is here at 0, right here, 0 and 20. So we know the domain is going to be time has to be greater than or equal to 0, but less than or equal to 20. The range, now the range is right here. The lowest is negative 13,000 feet. The highest is 0. You can't have the submersible flying above the water. So we know the submersible is going to have a minimum height or depth of negative 13,000 feet, which is less than or equal to the height, which is less than or equal to 0. So now we have to interpret. It says in the problem, interpret the slope. So what's the slope? The slope is 650. The slope means it ascends at a rate of 650 feet per minute. So now we look at the intercepts. So we need the y-intercept. So what does the y-intercept mean? Well, the y-intercept is what? It's 13,000 feet below, negative 13,000. So what does that mean? It means that negative 13,000 is the elevation of the submersible. The negative 13,000 feet means that's the elevation of the submersible. And lastly, so we have slope, we have y-intercept. We have to understand what the x-intercept is. So the x-intercept is what? Is 20. What does the 20 mean? The x-intercept, 20 means it takes 20 minutes to reach an elevation of 0 feet. And you may have noticed I forgot something in the y-intercept. It says the y-intercept is negative 13,000. And that does mean that the elevation of the submersible is negative 13,000 feet. But when? When it begins to ascend. So I forgot to put that in there. That's important. We have to explain that the y-intercept, we have to explain the 0. That time is 0. So when it begins, the elevation starts at negative 13,000 feet.